Welcome to a new audio case study on the Efficiency and Reliability Podcast. In this episode, we'll take you inside a fourth quarter 2024 turnaround at a Saudi Arabian refinery where significant corrosion challenges threatened critical equipment. We'll explore how HVTS technology provided a faster, cost-effective, and long-term solution compared to traditional repair methods. During the turnaround, the refinery faced severe corrosion across 4 key equipment units, including areas where existing weld overlay protection had partially failed. The conventional repair approach, which is welding with mandatory post-weld heat treatment, was not feasible due to time and cost constraints, especially given the variety of base materials and weld transition zones requiring protection. The equipment treated included the heat exchanger nozzle, heat exchanger shell, rich amine drum impingement plate, and net gas scrubber nozzle. The project was executed with a flawless safety record, ensuring full compliance with the refinery's confined space and equipment requirements. Air horn ventilation was used for confined space applications, and dedicated QC representatives oversaw comprehensive quality control measures throughout the project. The HVTS solution delivered multiple key advantages over traditional repair methods. The cladding was applied directly over failed weld overlay areas after appropriate surface preparation, eliminating the need for complete weld removal and replacement. HVTS is particularly effective at protecting transition zones and dissimilar welds. It does not require specific welding procedures for different material combinations and can be applied to any base material without additional qualification procedures. HVTS eliminated the need for post-weld heat treatment and concerns about heat-affected zones, providing a crucial metallurgical upgrade for highly corrosive environments. The technology also prevents distortion caused by welding heat input. The application process was 3 times faster than traditional weld overlay, creating a dense, impermeable barrier with superior erosion resistance. The coating also demonstrated excellent resistance to vessel steam-out and cleaning processes. Looking ahead, IGS recommends ongoing equipment monitoring and extending HVTS application to larger areas in future shutdowns. The plant is considering HVTS as a proactive maintenance strategy, particularly for transition zones, dissimilar welds, and similar corrosive environments in other units. The business impact of this project was substantial. By eliminating the need for post-weld heat treatment and the extended downtime it requires, the refinery saved 10 to 12 days of turnaround time, equating to approximately $36 million per day at 2025 market prices. More importantly, it provided a robust, long-term solution for protecting critical assets against aggressive corrosion, demonstrating the value of innovative surface protection technologies in modern refinery operations. And that's it for today's episode of the Efficiency and Reliability Podcast. Thank you for listening, and we'll see you on the next one.